Good afternoon to everyone, and welcome to this webinar about MangroviaIoT, that is an IoT data management platform developed and sponsored by Sorint.tek. I'm Leonardo Belotti. I'm a data analyst working for this company, Sorint.tek, and I'm involved in the development of MangroviaIoT since January. I'm also a management engineering student with a strong passion for technology and innovation, and I'm happy to share with you today the work that we have been doing with Mangrovia and to give you an overview of the IoT sector. So today we are going to talk about MangroviaIoT. We will have, firstly, a brief introduction about data management in general, with some references to MangroviaIoT. We will have also the opportunity, thanks to a colleague of mine, Ilaria, to have a journey on the platform where she will share with you some of the basic functionalities of the platform, sharing her screen. After that, we will have 10 minutes, 15 minutes break, and we will go back with a technical content. So MangroviaIoT uses many technologies, and I want to present you now one of them, that is the Mqtt Broker. In particular, we will go through the Mqtt protocol, because it is a standard nowadays in the IoT industry, and it can be an opportunity for you to learn this protocol that can be applied wherever in this industry. Then we will have again 10-minute breaks, and we will come back with a lab with me. I will share my screen, and we will try to make a Python application exploring the functionalities of Mqtt. So let's start with this introduction about data management. So actually, IoT data management platforms are data management platforms, and so by definition, they help us in collecting, keeping, and using data in a secure, efficient, and cost-effective way, so that people within an organization, from business people to operational people, can take better actions. So they can take better decisions, they can get support for their operational activities, and gain some benefits for their organization. So let's make a step back and start talking about data management in general. So data management is a quite known concept that refers to the processes of keeping the data organized to extract information from that. The process of data management starts with a good governance, so with the definition of proper methodologies, proper ways of handling all the processes related to all the data lifecycle. The governance is also responsible for defining some review mechanism and ensuring the quality of the processing we are dealing with. A good governance is also important to ensure that all stakeholders are aware of the benefits that the platform itself is generating. And so people involved in the governance should inform all the others about the good decision that have been taken by using efficiently the information. So after the governance has been properly defined, we can move on trying to define the data content. And so what data we need, what sources of data we need to interrogate, what is, for example, the sampling frequency, the speed of the data flow. And we have to ensure that this data that we are collecting is an high quality data, which means it should be free from some inconsistency, from some errors, some problems that can happen with the process of the data collection. Ensuring data quality is fundamental. We can't make analysis if we have low quality data. But after we have defined the governance mechanism and the data we are dealing with, we have to define who are the stakeholders, the users, the people that will have access to this data. So generally, data management platforms allows authentication and authorization, so different levels of authorization with different types of users that have visibility over certain content. We have to ensure that stakeholders have a complete understanding of the data they are using, and that they have access to all the data and only the data that they need. At the end of this process, we have our output, if we want, that is the decision. So we do all this work in order to take better decisions, to get more knowledge about the context, and to get a competitive advantage, to get the good strategic decisions, but not only from a management point of view. We can also try to connect to the platform or integrate within the platform some advanced analytics tools that allows to generate, to create some predictive models to get additional information with a very low level view, with a deep insight over the content of the data. So these are the principles of data management, and these are handled mainly in the data management platforms. So data management platforms are very heterogeneous. We have many types of these tools, but in general, they have 4 elements in common. Of course, they need to collect the data, to persist the data, and also to clear it, maybe based on some retention mechanism. After some time, we need to clear the data that is no longer useful, again, to ensure the quality of our data source. Another common element is about the processing. So getting the data that have been collected, and make some computation, extract some metrics, some KPI, some useful metrics to analyze what we have in the platform. Another common element is related to monitoring. So data management platform can often be viewed as a sort of a control room where users have access to many notifications, alarms, pop-up, to get know the status of all the different assets they are monitoring with the platform. And in the end, the last common element is the visualization, the presentation of the data. So we have all this stuff in our platform. We wanted to make sure that with the proper graphs, the proper visualization tools, the proper charts, the users can see them and can make a decision on that. So these are elements that are common to all the data management platforms. What does IoT change? Well, in the IoT industry, everything remains the same, but we have a lot more of heterogeneity. So there are different types of data collected coming from different types of devices with their peculiarities, with their sampling frequencies. For example, in the previous webinar, you should have seen the Snipe project. In that project, the peculiarity was the sampling frequency. We get data at 5 kilohertz, and we need to process them accordingly to this high frequency level. Then we should process the data, and again, heterogeneity affect this data, this element. Since we want to clean our data to have a consistent database, to have to extract the right information, we need to adjust our IoT data management platform according to the context. So let's recall again the Snipe project. In that situation, with the Snipe project, we collected metrics from a furnace area related to conveyor belts and the vibration. As I said, the sampling frequency was so high that sometimes it could happen that some measurement errors occur. And so we added within MangroviaIoT some filters to eliminate the measurements that were outlier with some moving average mean techniques. Then we have heterogeneity also in the monitoring phase, because again, due to the various nature of the data that we are collecting, there are many anomalies, many exceptions that are specific to the sensor that is sending the data. And so the monitoring should manage in a custom way this exception and should handle them properly. Again, let me recall one time more the Snipe project. In that project, we collected the metrics from humidity sensors related to the humidity of the sand in the furnace, and we wanted to notify the operators about the danger of the situation, and so we sent from the platform to some wearable device, to some smartwatches of the operators, the exception, so they were alerted. In the end, the presentation phase is also affected by the heterogeneity introduced by the IoT industry. With Mangrovia, so Mangrovia is involved in and used in many different contexts, from energy management to smart cities, to predictive maintenance, to vigilance and surveillance, and it's important to show a result that is bounded to the business needs of that specific project. Okay, to handle with this heterogeneity introduced by the IoT industry, we need to be flexible. We need to have flexibility in the product and flexibility in the process. What does it mean? Being flexible in the product means being able to deploy an application, a platform that can be customized without too much effort, and trying at the same time to balance this customization with generalization, because we are collecting different types of data, but we want to keep an homogeneous view over this data. Flexibility in the product means also scalability, for example. So being able to scale vertically or horizontally based on the load that the platform is facing. And we need also to be flexible in the process, which means having a team from managers to developers that tries to face quickly the changes and the new requests of customers. Being flexible in the process in MangroviaIoT means apply an agile methodology and the modern application development techniques, but also from a developer's perspective to use CI/CD integrated tools. So continuous integration and continuous development practice to actually allow developers committing small and incremental changes that are then collected into a central repository where some automatic tests are done, and then the changes are deployed automatically in the production environment. So that's it. This is a very high-level overview of data management and IoT data management platforms. I think that's now time for a colleague of mine, Ilaria, to bring you on MangroviaIoT and show you the basic functionalities of Mangrovia. So let me give her the stage.
Good afternoon to everybody. I thank you, Leonardo. I just spend some minutes to show you MangroviaIoT and the IoT platform we developed in Sorint.tek. As Leonardo said, an asset management and operational intelligence platform is one of the crucial components needed to speed up data acquisition, to define analysis process, and to translate the IoT into business value. MangroviaIoT is the result of many years of experience in software development and advanced analytics in the enterprise IoT sector, in particular in the utility and energy sector, for rollout and management initiative of large volume of smart meter. Based on this experience, we developed a solution aimed at improving business processes as Leonardo said, of fast implementation, scalable, flexible, and able to adapt itself to heterogeneous context. MangroviaIoT is a modular and multi-level infrastructure and answered to three main objectives. First of one, Mangrovia manage and monitor the state of the device infrastructure. It is important to know if all the devices throughout the territory are communicating or not. This is very important because it is important to have data consistent and well built. So first one, the monitoring of state of device. Second objective is to collect, store, monitor, and visualize data from sensor. Sensor read information in the reality, send data, we have to read it. And third, last but not least, it able to create a database useful for all kind of the advanced analytics. So useful to have a data bank necessary to adopt statistical tool or machine learning algorithms aimed at the development of predictive and prescriptive analytics. So these are the three main objectives. What a user entering in the application can see. First of all, as I said, the vision of all the sensor. As you can see on the left, you have this is a demo ambient, so there is a limited number of devices. But for example, I can see that I have 11 devices installed and only one not communicating, and the other 9 are communicating. One is in maintenance, and means that I know there is a problem. I put it in different status, and I don't use it to make a statistic about the state of the infrastructure. In this graphic, I have a complete overview of my infrastructure, while on the right side, I have a detailed table with all the information about my sensor. I can see exactly which kind of status they have. I have some information about them, a friendly name, a MAC address, or a serious number. I have the typology, the producer, or the address where they are located. I can add other information if I want, and I can group the device into specific group. This is because, for example, if I am a company, I can decide to have a different kind of device and different kind of user monitoring a specific group of device according by typology or need or process. I can have also different type of device, physical device or virtual device. What is a virtual device? Is something that is really similar at a KPI, key performance indicator, means I can build an indicator adding or aggregating data coming from the reality. I will show you an example, but first I go through the application because after this overview of the infrastructure, I go through directly the specific sensor. For example, the first one, I select the third row, and on the left side, I will see exactly the data at the last lecture, the last reading. Of course, while we are in a demonstration, so I have to refresh all the application because it was in standby. This is the demo effect. So I find my my list of device, and I select the third row, and I have the last data read by the device. As you can see, the data and the date and the hour is really in a real-time reading. I can have the same data for each of my sensors, so have a really real-time idea of what the sensor, the device are reading throughout the territory. But I can also know what is the story of this data. For example, about this sensor, Officina, I want to know about this kind of register, we call it register. This is the type of measure that this kind of sensor sent to MangroviaIoT, I can have an historical trend. Let me say that we have a kind of, I show you a kind of device that is typical of the term of energy management, but in fact we can have a different type of device, and so maybe the measure can be completely different. It can be the humidity level, the door opening, or the pollution level obtained by measure the PM10 level or other indicator. Or we can have an indicator about movement of a building, and so on. There can be a very wide number of sensor and measure we can obtain and collect through this platform. Come back to the point. It means I will show you how we can see the historical trend of a measure. For example, this. I can see historical, so all the measure I can see, active power, current, power factor, and so on, they have an historical trend that is by default on the last 7 days, but I can choose on a different period, for example, a month, last year, 3 months from 1st August to 3rd August, and so on. So I can choose the period. I can choose the granularity. It means I want to have a data each quarter, each hour, each month, daily, and so on. Because of course, if I had a 7-day period, it makes sense to have information or each hour. But if I have a period as 1 month, maybe it's easier to visualize data with a frequency daily. As I said, here you can say all kind of trend of each register. I can also decide to make a zoom on a specific day and try to have which is the value that I want to know of a specific point. For example, I want to know exactly when I have this point break, and I can see a specific hour. Also, I can extract all this information and have make it in a Excel file. But we have other information that we have the possibility to look at all this device in a georeferential way by going through a map. This is Google Maps, and as I can see, I have 8 devices near Bergamo and 3 devices near Piacenza. Okay, I can zoom and know exactly where they are. I have the maintenance device near the airport and the other in the Sorint headquarters, and they are all communicating, and I can click on one of them and know exactly which is this one, and then go straight on to the data they send us. So from the reality, from the territory, through the directly through the platform. And come back to the map if I want. Okay, this allows us to have really an idea, a vision completely wide of where there are the device and which is the status of the platform. I can also have a different map if I need to understand exactly where are situated the device. Okay, let's come back to the main form, that is this one, because I want to show you another functionality before to pass to the dashboard and to the personalization that the user can do in the platform. Another important point is that, as I said at the beginning, we can obtain some virtual counter, and we can make relationship through the device by build a sort of hierarchy. I made one for you. I close all the branches, and I can see that I have two main branches. One, the headquarters Bergamo, that group all the devices that they are installed in the headquarters, and another one is in Piacenza site. As you can see, in Piacenza site, I see immediately that there is something wrong, that is some device is not communicating, because I have a pink color in this row that tell me that something in the branches of this hierarchy is not communicating, so that I have to say to a team to go and verify why the device is not communicating and resolve the problem. Another important thing that with this kind of visualization, I can go ahead and visualize the data of the single sensor, as I showed you before, but I can also build an information general information about, for example, the sum of all the, for example, the energy consumed by all the device that I put in this branch. So, for example, in the headquarters Bergamo, I built a virtual counter that I called total energy consumed headquarters, that is built like a sum of all the total active energy consumed I had in the sub-branches. So this instrument wants to support a user. It is a simple, very simple example of how not only we can have data in real time, but we can have KPI updated in real time that we can monitor in order to make decision or define action and so on. For example, we can, through this application, define a notification mail in case of an indicator or a register is up through a limit we define, or up or we can, in this case, the list of our device will have one of them in red color, indicating that the one of the register is up of the limit that we defined through the application. And we can also define that in this case, a notification mail is sent to the people who has to do some action important for our internal process. So I try to summarize. With this application, we can read information, aggregate information, and make KPI useful to make choice or to do action. Or to monitor some information, because we can also, for example, I come back to the total active energy consumed. I can see how is moving this information during the last 7 days or another period I define and decide to visualize. And this is very important, not only in order to monitor and know and understand exactly what is happening in my company or in my town, my city, but also because sometimes the regulation, the state regulation asks to company to measure specifically some, for example, energy consumption, in order to demonstrate that action that company can apply in order to make efficiency are real efficiency, obtain the goal they declare they want to join. I don't know if I really if I've been really clear, but what I want to say that is that a measurement system as is Mangrovia allow people also to demonstrate that with a measure concrete, that what I have defined in my company, the action I put on the table to modify my energy consumption have a real effect, a positive effect. I have another point to show you, that is the possibility to build personalized dashboard, then allow the user to monitor specific measure. So if the dashboard, device dashboard I shared you before is fundamentally for someone who has to monitor the infrastructure is up, everything is going well, there is no problem. If there is a problem, I can act and resolve the problem. This dashboard is used fundamentally by a person who want to monitor specific indicator. For example, I can build any kind of dashboard. I can build many of them by selecting and putting in the same widget a different kind of register from different kind of sensor according with my need of monitoring. The system is a demo system, so it's a little bit slow in the data upload, even because, for example, I tried to compare the power factor of a specific device July data with August data, just to understand if there is a difference in this kind in the trend of this data. But I see that is a little bit no, it's arriving with some problem. So I changed my dashboard, and for example, I share with you this other that I built before in order to, it's a dashboard that want to show the punctual data of 3 different devices installed in 3 different areas of my headquarters, and the historical trend of the end quarter, obtained by the energy consumed of the 3 area, obtained in the 3 area. What we can do is build another dashboard and select the device we want to put in this dashboard, the form of graphics we want to obtain, so a punctual data graph, or a trend, or a graphic used for visualize the alarm history. I select, for example, historical trend, and I select the register I want to show and to monitor it, because the point is that I want to monitor a register. I build a dashboard, and I can see the real data, in real time the data, every time I go in the dashboard and I visualize what, and I open again the dashboard. I'm not very lucky because this register is always on 0, but I can add another one and compare and in this case I compare two different measures of the same register. So as I try to summarize, you can build how many dashboard you want. Each dashboard can have how many widgets you want, and in each widget you can put different measure from different device or from the same device but in different period of time. And you can build also widget to monitor punctual data or the status of alarm. What is the status of alarm? As we come back and then we finished our presentation. If you come back in this first in the device list, I told you that if you select one of the device, you can see the punctual data, the historical trend, but you can also see if this device has been in alarm in the last 7 days or in a different period. In this case, no, it has also always been with no anomaly, so it is a device, it is always communicating. But if it happened that there is some problem, there have been some problem, we will see some pink area indicating that in some period the device has not communicated. This can be useful because, as I said you, one of the important things of this platform is to obtain a database with data well done, with no true, with no wrong information, with a continuity of the information. This is a consistent database. This is an important thing in order to apply algorithms and make advanced analytics. Who is the next step after build an IoT platform? I suppose this can be an overview of the MangroviaIoT platform. If you have any other question, do not hesitate to write in the question area or in the table area that you can join at the end of the webinar. I pass to Leonardo the possibility. I pass the word to Leonardo. He can go ahead with the presentation. I hope I've been clear enough.
So thank you, Ilaria, for your presentation. So now it's 15:15, so I think we can have 15-minute breaks, and I will go back soon at 15:30 to expose you the next concept that is going to be drilled down on the Mqtt protocol. So we are going to enter more into the details of the technologies involved in MangroviaIoT. And okay, so see you then at 15:30. Okay, here we are after the break. So we have done our journey on MangroviaIoT that, as I've said, uses many different technologies. Most of them are open source. One of them is the Mqtt Broker of RabbitMQ. That is an implementation of the MQTT protocol. So now let's try to take one element of MangroviaIoT, that is the Mqtt Broker, so the communication layer, and let's try to go more into the technical details. So let's start with a little bit of history. MQTT was created in 1999 by two engineers who worked at IBM and Eurotech, with the goal to connect some oil pipelines in the middle of the ocean and reach a stable and reliable communication from some sensor, from some SCADA systems on these pipelines to the earth. So actually they had many challenges in managing this complex project. One of them was that they had to deal with many different devices, and so they wanted to create a protocol that was very easy to be implemented and that doesn't require complex manipulation of the existing systems to be implemented. So the basic concept here is that the MQTT protocol is very simple to be implemented, and it is mainly because of this reason that it has become so popular nowadays in the IoT industry. So being simple to be implemented is not only related to the competencies that a developer should have to implement it, because it has another important advantage, that is the fact that it requires less code to be implemented in the sensor. And so less code means less resources, and this is particularly important for IoT devices that very often are really constrained. Another property of the MQTT protocol is that it gives the possibility to define the quality of service delivery. So you can specify how certain a delivery of a message should be. So you can be absolutely certain that the message will be delivered and received only once, for example. But to have this complex level and high level of service, of course, you have to pay in terms of efficiency. MQTT is a data agnostic protocol, which means that you can send over the network whatever you want. You can send a JSON, you can send an XML, you can send a string, you can send binary data. So everything is encoded in byte, and then if on the other side there is a receiver that decodes the message properly, you can communicate with the format that you prefer. This functionality is strictly bound to the simple implementation I was referring before, since, as said, these two engineers had to deal with these SCADA systems that were very different the one from the other. Having a data agnostic approach was very helpful. Another important element that was taken into consideration when the MQTT protocol was developed in 1999 is the fact that it is very lightweight and bandwidth efficient. So this is due to the fact that Messages has a very limited overhead, packet overhead, and so actually they consume very low bandwidth, and this gives us two main benefits. The first is that it costs less. Well, actually, this was important at the time of the implementation, since satellite communication was very expensive. But the second, and that is most important, more important nowadays, is that sending less overhead allows the device to keep the charge, keep the battery charge for a longer time, and so reducing the frequency of changing the batteries to devices. And in the end, Clark and Nipper needed a protocol that was continuous session aware. So a device in a network should be able to identify itself uniquely, and it can disconnect and then reconnect without losing its original state. So after some time, 2011, and then with a review in 2013, the Mqtt protocol became a standard, and from that point on, it has been widely adopted in the IoT industry. So, but let's go more into the detail. It is a publish-subscribe pattern protocol. So there isn't a communication client to server, but instead we have a network of clients that, for simplicity, I call the publisher and subscriber, but they are all clients, the same features. And the communication is handled thanks to a central component that is the broker. So a publisher sends a message to the broker that is responsible to filter it and sending it to the right subscribers. The pub-sub pattern brings many benefits. For example, it allows decoupling. Space decoupling refers when we have a client that has to speak only with the central broker. It doesn't need to know where are on the network, the other devices. We can configure a publisher at a certain point in time, and after 2 months, for example, we can add another subscriber. And this is very transparent for the user, since everything is managed by the broker. The pub-sub pattern allows also time decoupling, which means that messages should not be consumed as soon as they arrive. For example, it can happen that a subscriber goes offline and a publisher continues to send messages, but there's no problem in this context, since when the subscriber comes back, he will get all the messages that he hasn't received before. The pub-sub pattern in the end allows synchronization decoupling, which means that messages are consumed and processed asynchronously. The publisher sends a message and it is fine with that. It doesn't have to wait for a response, because he's sure that the message is handled by the broker and will be delivered as soon as the subscriber is ready for it. So we can understand how this configuration is suitable in comparison, for example, to the HTTP protocol in the IoT industry, where we have multiple devices with a one-to-many communication often, and they all rely on an unreliable network. So, how the broker can filter the messages that are sent by the publisher? There's a simple rule that is based on topics that the broker uses to split and deliver messages to the right subscriber. So, topics are just strings with a hierarchical structure, as for example, we can see Italy, Rome, building 15, status, that are used by the broker to split the messages. So let's imagine that here a subscriber subscribes to this topic, Italy, Rome, building 15, and status, while the other one instead is interested in the temperatures. Clients receive the message from the topics they are subscribed to. So in the next step, the broker will publish the message following this simple rule. Why do topics have a hierarchical structure? Because they allow subscribers to use wildcards to subscribe to topics. For example, let's imagine an easy application in which we have a sensor that publishes some metrics that are visualized on a front-end dashboard and persisted by a backend server. So maybe the backend is interested in persisting all kinds of data to keep consistencies, and so he can subscribe using the hashtag wildcard to all messages after Italy, Rome. So he will get, if you remember the original structure, he will get all the messages of temperature and status from all the buildings in Rome. But we can have also a one-level wildcard, the plus sign, in which actually with this pattern, the front end can get only the status information for all the buildings that are placed in Rome. So, for example, in the front end, we can have a dashboard to visualize only the status of the device, and we are not interested in getting also the temperature information. One of the most interesting aspects of the MQTT protocol is the quality of service, and in particular, the possibility to define a quality of service, so a guarantee of delivery for a specific message and for a specific topic. We have 3 different quality of services. At most ones means that there is not an acknowledgement after the message is published, so we have no guarantee of delivery other than the underlying TCP/IP protocol. And with quality of service 2, instead, we have a message that is delivered at least once, which means that it can be sent more times, but for sure, at least once it will arrive. And the third quality of service, exactly once, when we are sure that the message is received and it is processed only one time. As you can imagine, the ideal scenario would be to use always the exactly once, since it can simplify applications. But actually, this is the most complex quality of service that the clients should handle, and this introduce a lot of overhead in the packets and make the communication slower and more complicated, actually. Keep in mind that within the pub-sub pattern, we have 2 levels of communications. The first communication is two-stage communication. We have the first communication from the sensor to the broker with a publish, and then from the broker to the subscribing clients. We can specify a quality of service for both the 2 stages of communication. So let's recall our example with a sensor that is sending the temperature and the status information to the broker. We have a backend that wants to be sure to get all the informations, and so defines a quality of service equal to 2, while instead the front end that we imagine should be a web app, very light and very responsive, indeed just wanted a quality of service 1, and if some messages are lost, it can make call to the backend. So note that the backend who wants to get all the information is using a quality of service equal to 2. That's not by chance, because usually in application development, it is preferable to use the quality of service 2 at least once, and deal within the application with duplicates instead of implement this less lightweight way of communication. So this is our simple application. In the second part of this tutorial, we will try to implement this simple application with Python. But before doing that, let's make some additional consideration, because everything's work well until everything is online. What happens if a client loses connection? So let's suppose that our backend client goes offline. It's a problem because we want to get all the data. We don't want holes in our history, in our time series. We wanted to keep them all. In doing so, we have to use persistent session. Persistent session allows clients to recover from disconnection. So if the backend goes offline, but it has a persistent session, when it comes back, the broker will send him all the undelivered messages that he could have lost. But note that the broker should know that it was the same client that was connected before. And so we need a client ID, a sort of unique identifier for each client. Well, it's actually not necessary for those that are not persistent, but for those that want to have a persistent session, we need a client ID, this unique identifier within our network. Another error can happen and can affect, for example, the front end. If the front end goes offline, The problem is that when it goes back, it doesn't know the current status of the sensor topic and of the sensor. Because let's suppose that a sensor is communicating once in an hour, so is sending messages periodically, one after the other, but with a very high interval of time, a very long interval of time. So once in an hour can be an hypothesis. So if the front end goes offline and that reconnects, you should have to wait a lot of time before getting a new message. And that can be a problem for our dashboard that instead wants to show the real-time information of the sensors. So how can we deal with this situation? The Mqtt protocol offers as a functionality that is called retain messages. It is just that are just messages with a flag, the retain flag, set to true. So if the sensor sends a message on this topic with a retain flag set to true, the broker will keep this message, and that's the important part, will send it immediately after a client subscribed to this topic. So when the front end recognizes and it subscribes to the Italy Rome plus status, and so also the topic of building 15, immediately the broker will send him the status information. Okay, let's consider another situation. So we have seen what happens if the backend goes offline. We have seen how we can deal instead with information and consistency when the front end goes offline. What if instead the sensor goes offline? So what do we expect in this situation? We have this dashboard with all the status of the device. It could be a good idea to show that our sensor isn't anymore connected. The Mqtt protocol in this situation gives us the last will message. So a sensor, but in general every client, can specify in the connection phase a last will topic and a last will message with also a retain flag that will be sent by the broker. It will be stored at the beginning and sent to by the broker when an ungraceful disconnect happens. So, for example, we have defined a keep alive interval period of 60 seconds, and the sensor goes down, and the broker didn't receive the keep alive message, so he will send to the front end, or because he subscribed to this topic, the message offline. Then it will be responsibility of the front end to handle properly this situation. So, okay, now that we have seen all the main aspects, so that let's just recall them. So the quality of service, the persistent session to allow recovery from disconnections, the retain messages that are stored and sent immediately after a subscription, and the last will message that instead sent when there's an ungraceful disconnect. We can try to look more deeply into the messages that are exchanged by the two parties. So the first message is always the connect message. A client specifies a client ID, a client session, which is the opposite of the persistent session that we have seen. So if we want a persistent session, we have to set clean session to false, and username and password for authentication. Last will message, topic, retain, flag, and the quality of service if we want to implement a last will mechanism, but it is optional, it is not necessary. And a keep alive interval in expressed in seconds. So the publisher sends a connect message, and the broker replies to him with a connect, so an acknowledgement that says if the connection has been successfully, so return code 0 in that situation, and if a session is already present with the broker. So if the broker has all the informations associated with that client ID in a previous session. Note that the connection is always between one client and the broker. Client never connect to each other directly. So there's always this pattern with the broker in the middle and a network of devices connected to the broker. Okay. Now let's see another type of message. We have the subscriber message. That is the message that is instead sent by the subscriber to subscribe to specific topics. It has a packet ID and a list of topics and the corresponding quality of service. It gets an acknowledgement as a response with the same packet ID to be identified as the response of this subscription, and the corresponding return code. So 0 if quality of service is 0, 1 if it is 1, 128 if there's an error. Of course, clients can also unsubscribe from topics. Just send an unsub message that will be followed by an unsub hack with just the list of topics you want to unsubscribe from. Okay, and the last important message is the publish. The publish that will send the content, the important content to the broker, and then will be sent by the broker to the clients. So here we have a publisher that sends this message to the broker with a quality of service equal to 0, that is specified within the message, a destination topic, I don't know, in this case, topic / subtopic, it is just an example, a payload, so the information that we want to send, and as I said, this can be a JSON, this can be binary data, whatever we want, and a duplicate flag. With quality of service equal to 0, if we remember, the duplicate flag is always set to false because no duplicates are sent. There isn't an acknowledgement from the broker sent back to the publisher. Things change when we move to the quality of service 1. In this situation, we send again a message with quality of service 1, and we wait for an acknowledgement sent by the broker. If one of these two messages are lost, then the publisher will send again the same message, but with the duplicate flag equal to true. So if the broker receives it and it has a duplicate flag equal to true, but it is the first time he sees this message because it was the publish that went lost, then it will deal with it, send a pullback, and everything goes well. The last thing for this second part is related to the publishing mechanism for the quality of service equal to 2. So in this situation, we have a publisher that sends again the same message. What changed here is just the quality of service equal to 2. Then the broker receives it and send a pubrec, so the publish has been received, and send back it to the publisher. Once the pubrec is received, then the publisher removes all the information related to this message. This message will not be sent again since it has been received. Once done, it sends the pubrel to the broker that at this point removes the pub receive information from his storage and replies back with a pub comp. So the publish have been completed. The last stage that we have is the publisher that removes all the information regarding this packet ID, and it will be able to send a new message with 5482 as packet ID. So as you can understand here, there can be some complexities introduced by the quality of service 2. So for example, a publisher that has very constrained resources, that has low memory, and that can communicate for a long time, accumulates messages that are not processed, and it causes the failure of the system because it doesn't have any available packet ID to use to send new, maybe most important messages. Before going into the lab about Mqtt and try to make with me an application with Python, using Python, let me tell you some examples of applications in which the Mqtt protocol is involved. So it's not only within the IoT, where of course, the protocol has found a green field and big opportunities to grow, but it is employed in other different scenarios. So, for example, the Mqtt protocol was adopted by Facebook to improve the Facebook Messenger capabilities. So it was used as a messaging protocol. So how this can happen? Within Facebook, you have as a user a Facebook ID, which is used as a client ID into the connect message to connecting to the broker. And then when you create a new chat with a friend of you, you are creating a new topic where messages are published and then consumed by your friend that is subscribed to that specific topic. Topics are hierarchically structured to allow also the load balancing within the servers of Facebook, generally load balancing based on geographical location. And I think an interesting thing is how messages are handled in groups. So as I said, it is a protocol that is very good for one-to-many communication. So try to think about how it is simple to deal with a kind of situation of messaging within groups with the MQTT protocol. You just need to publish a message into a group topic. It is just a topic, is the topic of the group, and every other client will subscribe to it and get what you have sent. So the question is why this protocol was introduced by Facebook. The real motive is that because of this minimum packet overhead, and so these lightweight capabilities, the attempt is to try to reduce the consumption of the batteries of the smartphones when using the Facebook Messenger application. Okay, so other applications are can be found also in robotics. For example, MQTT protocol is used for handling the movements of robots, of the different components of the robots, by sending proper messages to the proper topic. And again, of course, it is widely used. It is a standard de facto nowadays in the IoT industry. And we will try together, after a short break, I think 10 minutes from now, to have a try to create an application with Python and exploring the functionalities that I've presented to you. So, okay, see you then at 16:20, I think. And just make sure you have the Python interpreter installed on your workstation. Also, the packet manager pip can be useful, but this is all you need, since we will use a public broker, and you can follow me without any complication. See you then. Okay, here we are again. So let's start with our lab. But first, I've seen that someone asked for the slides in the chat. For everyone that is interested, you can
Leonardo, scusami, non si sente la voce.
Thanks, Arianna,
Ok.
for your intervention. So I was just saying that if you need that someone in the chat told me that he wanted the slide. So if you need the slides, I'm available for sure to send you and send them at send me an email so that I can reply to you. My email address is this one, and so now we can start with our lab about MQTT and implementation of the MQTT protocol with Python. So again, let me do this check again. So just verify that you have Python installed on your workstation. I'm using Python 3, and that you have the Python official package manager, that is pip, installed, because we will need to add a few dependencies. Okay, so we needed to use a public broker to test our application. We can use this one, broker.hivemq.com. Here, this is just it's MQTT Explorer. It's just an application to connect to some brokers. Since it's public, we don't need a certificate, we don't need a username or a password. So let's just try to connect to this broker. Remember that this is public, so everything that you publish can be visible to other users, and so don't send confidential information. You can make a subscription to a topic. For example, we can use a wildcard, the hashtag, to get all the messages that have been published under this root topic. Once we have done it, we can see that someone already published something onto this topic. So, for example, here there's a goodbye, is still coming. Also, this beta fence seems to communicate. So I'm just doing some tests on this public broker because this is the one that will be used. I want to show you a thing that is that as soon as I connect, I will get immediately 29 messages. And the reason is that, for example, this message, hello from laptop, was sent with a retained flag set to true. And as I said, as soon as I do a subscription, I will get this message. So, okay, MQTT is not necessary for this short lab. We will use it just for debugging. Okay, so now let's create a new directory. Let's call it, I don't know, Mqtt project. And let's enter into it. Here we're going to create a virtual environment that is a Python environment where libraries, scripts, and packages are isolated from other environments and from the default one that is your operating system. So let's create a new virtual environment, my venv, for example. And I can check within this directory that something has been created. It is a group of files and folders with also a pointer to our Python interpreter, this Python 3. We can activate our virtual environment by calling the activate script. And as you can see here, we have activate our virtual environment. Everything that we install with pip will be limited to this virtual environment. Okay, so now let's create a new project. I'm using PyCharm as IDE, but really you can follow me only just with the Python console. And so let's create a new project using a previously configured interpreter. And here I'm going to choose that one that I've just created. So here I created a folder that's called Mqtt project. Within bin, I've got a Python file. Let's select it and let's create a new project. So this will take time, and until we are waiting, let's start installing everything that we need with pip. We just need a simple library that was that is Paho Mqtt. So it's a bit lacking. Paho Mqtt. Pip install. So let's do pip install Paho Mqtt. So now I don't have the wheel for building quickly the packages, but we can check that Paho Mqtt have been installed by going within settings, interpreter. it is loading. And here we should see the PAHO Mqtt library that have been installed. Okay, so that's it. That's all the configuration that we need. And now we can start. Okay, so let's start by using this package. And so let's import PAHO Mqtt client. I think it's just smaller, so let me try to zoom a little. I think that there should be sort of presentation mode. Okay. Okay, now it's bigger. So let's import the client class from Power Mqtt.client, and here we're gonna try to just publish a simple message onto this broker. So let's define our broker, that is broker.hivemq.com. We can use a client ID equal to my client ID, and let's add something because it has to be unique. And let's define a run function. So we will need a client, it can be the sensor. It is equal to client Mqtt client with a client ID equal to the client ID that we have specified. And we just need to publish a message to a topic, temperature topic, that can be Italy, Rome, building 15, temperature. Okay, so we have created this client. Let's connect to the broker. Let's start the loop, and let's publish a message. On the topic, temperature topic, a message with a payload equal to, I don't know, 15 degrees. So what is this loop start? This loop start can enter with a functionality of Power Mqtt.client. It allows to create a new thread where the sensor will be executed, and our client will be executed without blocking our main application. So the flow of the application continues, and there's our client is communicating with the broker that is running in the background. So let's add an input here so that I can control when things happen. And when I send another input, let's close the loop. Okay, so that's it. Let's try to see if I can publish something on MQTT. So let's make a subscription to Italy, Rome, building 15, temperature. Let's connect. So this topic hopefully is empty. Let's try to send a message. So here there's a problem. Name of service unknown, maybe I misspelled this. Yes, broker.hivemq.com. So we are here waiting for the first input, and then a message has been published. Italy, Rome, building 15, temperature 15 degrees. Okay, now the problem is that if we are using a public broker, we can come into many conflicts. And if you are publishing all to the same topic, we can interact, unfortunately, the one to each other. So let me just add a new class. How can I go out of presentation mode? Open this tab, okay. Let's create a file called Encoder, Python file that does a very simple function, takes as parameter a name, the string, and creates an encoded name randomly. So starts. So it used the join function to concatenate random characters, taking at random from the ASCII letters. And let's say that we want a string of 10 letters. So just take a name as parameter, create a random value, update a sort of store that is just a dictionary, so that we will be able to decode this value and return the encoded. And so we can also decode the encoded value by accessing the store and get the original value. And return the decoded. Okay, so very simple. We want to encode a value, just creating a random string and updating it and inserting it in the store. And then when we want to decode it, just get it from the store. Let's make a test function. So we have a name equal to test, an encoded value that will be the result of the encoded function. Let's log something like name has become encoded, and then decoded, and log it. So, okay. Let's see if everything works. Instead of running run, let's run a test. It says that I'm still executing this, and also I need to import encoder so that I can call the test function. A little laggy. The compiler won't help, but oops. The encoded should take the encoded value and show it as being decoded. So the sense is that with these simple functions, we've started from a test name that has been encoded, and then with a random generated string, and then our application is able to get back to the original value. Let me add another additional step, then we'll focus on Mqtt. So let's define, because we are working with topics, also encode topic that takes a topic as argument and split the topic into a list. Then for each element in this list, it adds just the encoded value. So encode level, and at the end we want the resulting topic with all names encoded. Let's copy it, and let's create also a decode topic function. And let's test it. Test sub topic. So here I'm just changing the test function so that we can see if everything's worked properly. Okay, so test subtopic has been transformed to this random topic, a random set of strings, and then our application is able to get back to the original string. Okay, now that we have our encoder that I think is useful for you to try to experiment with a public broker without the risk to get some interferences. We can try to create our application using the encoder. So the client ID will be randomly generated, and this is going to be something corresponding to sensor. So encoder.encode this. The temperature topic would be encoded too. And we will connect with a client with a client ID, sensor ID. We will publish to the temperature topic that has been encoded, and we will see if messages are gonna arrive. So we can make first try, just print something. The topic is temperature topic. Let's see what it happens. I'm executing the test. So this is the topic in which we want to publish. If we get back to our Mqtt application, and we subscribe to this strange topic, we will get our message. 15 degrees. Okay, so this thing just so that you can practice for your own without interfering with each other. Okay, so now let's add some additional logic to this, because we have said that we have a sensor, but we have also a backend with its ID. Also, this one will be randomly generated. I'm going to create a new client. Let's call it backend with the backend ID. Also, the backend has to connect and then the sensor will publish to the temperature topic this message, and we need a backend to get this message. So the backend will subscribe to the temperature topic. Since we want high availability, let's specify in the topic subscription and in the message publishing a quality of service equal to 1. We have started the loop also for the backend. We have to close it. So they are running in a separate thread. How we can get an alert when an event occurs, we can use the supported callbacks of this library. So if we look into the client class and we search for an on connect method, we see that it is quite well documented a set of callbacks to specify to the client in order to execute actions when some messages are sent by the broker to the clients. So let's define an onConnect method using the parameters that we have taken from the documentation. And what we're going to do, we are going to just say that we have received a message that we have connected to broker. So client ID. The code, since the client ID is in byte, so we have to decode it using UTF-8. And also we have to decode for our convention of the random generated string. So this client has connected successfully then maybe we want a callback for a subscription. So again, let's move into the client class. Let's search for something like unsubscribe, and we can get it. So let's see what it says. Unsubscribe is called when the broker responds to a subscribe request. This is what we need. Let's implement it. Def unsubscribe. Already copied. Just to say that the client has subscribed successfully. And then, in the end, let's define also a callback for notifying when a message has been received. I think that this is on message callback, but for sure, let's look into the documentation. Okay, so I've taken the on message callback, and we are gonna say that the client has received a message let's take this message class that has a payload attribute, and let's decode it using UTF-8. So the client has received a message, the name, the value of the message on topic message dot topic to be encoded. So encoder dot encode topic. Okay, let's do the last step. Before connecting to the broker, we have to specify the callbacks that are called by our clients running in backgrounds on their own thread. So sensor on connect is equal to on connect, backend on connect is equal to on connect, sensor on publish. Now we haven't specified an on publish message, so just use the subscribe method. So sensor on subscribe is equal to on subscribe, and backend on message is equal to on message. What's the logic of our application? At the beginning, both clients will connect to the broker, then the backend will subscribe to the temperature topic, then the sensor will publish a message on the temperature topic, and that's all. So sensor has connected successfully. Backend has subscribed successfully. Backend has received a message 15 degrees on topic, and this is our topic. So this is incomprehensible. So I think we have made a little mistake. Yes, here we have to decode the topic, not to encode it. But okay, it seems working quite well. Just log here that we are publishing a message. So print sending a message on temperature topic. And let's start it once again. So sensor and backend connect. Backend subscribed to the temperature topic. Then a message is sent on temperature topic, and it is immediately received by the backend on the topic Italy, Rome, building 15 temperature. And that's all. Okay, let's try to increase the complexity. So we have said that the backend needs to have a quality of service equal to 1 because we want to get all the different messages. And so let's suppose that the backend goes offline. We want it to be able to get also the messages that went lost. So let's specify here where we initiate the client that this is going to be a persistent session. So a clean session equal to false. Then we are going to subscribe to the topic, to the temperature topic with a quality of service 1. The sensor is going to publish a message on that topic with a quality of service 1. But before doing so, we want to disconnect. So backend disconnect we need to stop the loop. Let's log something very easily. Backend disconnected. Is now offline. Then we want to send the message, sending a message on temperature topic while backend is offline. And reconnects again. So backend connect, backend loop start. Connect to the broker and start the loop. Let's wait again an input from me and stop everything. So just see again what is going to happen. At the beginning, sensor and backend will connect, then the backend will subscribe to the temperature topic, but it will go offline. The sensor publishes a message while the backend is offline, and let's see what happens when the backend goes back online again. So sensor has connected successfully, backend has connected successfully, backend has subscribed successfully, backend is now offline, so the disconnection happens. Sending a message on temperature topic while backend is offline. Backend has connected successfully, and note that since it has a persistent session, it immediately gets this message 15 degrees on the temperature topic. And everything ends. Okay, let's add another additional step just to explore more the possibility that we have writing just a few lines of code. So let's specify a front-end ID. And encode the keyword front-end. The front-end is interested into the status topic, Italy, Rome, building 15, status. The front-end will initialize a client that has a clean session. Need to specify the callbacks, just copy those also for the front end. Sensor subscribe also for the front end. Subscribe callback. Backend on message and the front end on message should be overwritten to understand that we are getting the messages. Then let's connect also our front end. Let's start in their own thread. So the backend subscribes to the temperature topic, to the status topic, and the front end also subscribe to the status topic with quality of service 0. Then what can happen? It can happen that I don't know, we can simulate a simulation in which the sensor is publishing a message onto the temperature topic and also onto the status topic. Payload line, for example, or online at the beginning. And they will get it. if everything's work. So they have connected successfully, they have subscribed successfully, and they have received their corresponding message. So the backend received all the messages, while instead the front end received only the status message online. We have seen that it's important for the front end to get an update as soon as it comes online. So let's simulate this situation. So let's suppose that at the beginning everything's work quite well, and so that both the backend and the front end are connected. Sensor publish message 15 degrees and online, and everything is all right. But at a certain point, failure in our server cause both the backend and the front end to go down. And front end are now offline. We can wait for another input, and then let's send 5 messages from the sensor, messages 5 for each topic, sending at least the same information, so that the payload is 15 degrees and they are online. Or maybe, I don't know, let's send that something bad happened and the status is not properly defined and it is offline. So sending a message on sending messages, while backend and front end are offline. Then, after my input, they will connect to the broker, both the front end and the back end. And at the end, everything's end. Let's check if I've done everything properly. Front end, loop start, loop stop, loop start, and loop stop. Okay. Now, we have seen that when the backend comes online, he will get all these messages. So we are supposing that the backend will get 10 messages after he has gone up, while instead for the front end, what will happen? We've said that it's important that as soon as it gets online, it gets also the status of the sensor. In other words, we need that the message sent by the sensor on the status topic has a retain flag equal to true. And not only this, but also those that are sent later on. Note that the front end doesn't have a persistent session, contrarily from the backend. So actually, you will not get all these messages that are sent, but only after a subscription, and that's the important part, after the front end makes a subscription, the topic status topic, you will get the last retained message. Okay, let's add just a few lines for logging. So at the beginning, they will subscribe, Sora will send messages, then when it goes offline, new messages are sent, then they go back online and they will connect. Front end will make a subscription to the status topic and everything ends. So let's see what happens. So sensor has connected successfully, backend to and front end to. They subscribe to the corresponding topic. Sensor is sending messages and backend and front end are online. So the front end and the backend has received all the messages. Backend and front end are now offline. We have a failure in our server. Sending messages while backend and front end are offline. And let's see what happens when they go back. So backend is connected successfully and it gets all the 10 messages that have been sent on the status and the temperature topic. And look at the front end. The front end has connected successfully, but since it doesn't have a persistent session, it isn't getting the status information. Then the front end, after the reconnection, will make its subscription, and so that it gets the last retained message offline on the status topic. Okay, that's it. I think that we are done for this presentation and this very quick laboratory. I hope that you have now some instruments to try to explore with the protocol. So actually Python is very suitable to make some tests, and I've Mqtt Broker, the public broker is quite always up and running, so you can try to experiment. But I'm always available. I have given you my email address for those that are interested. For those that have some questions, you can contact me, and I will be happy to try to help you. Okay, so that's it for today. I will wait you in the table room. So if there's someone that wants to make questions, feel free to join the table room. That's in the platform. That's in the download platform. So try to navigate. I think in the right low corner. So have a nice evening, and thanks you for staying with me today. Bye.